Good morning, all of you. Please switch off your camera.
गुड मॉर्निंग मैम।
मॉर्निंग, गुड मॉर्निंग। किसकी क्लास है?
भाभा सर की।
नेविगेशन।
ओ, ठीक है।
Hello, beta. Good morning, everyone.
Good morning, sir.
Good morning. Sorry, I got a little late. I was in second mate's class. Their exams is going on today. So anyway, let's continue with our topic. So what about your assignment, beta? Is the composite sailing assignment completed?
Yes, sir, completed.
Okay, all right. Very good. So let's continue on our next topic then. Next, we will be picking up celestial navigation, and in celestial navigation I will first cover up the concept of celestial sphere and different systems of reference. One is the equinoctial system of reference, then we have the horizon system of reference, and once we cover up these two, then we move on to the PZX triangle. The PZX triangle and how to solve it. So this is the next thing which we are going to pick up. So before I open, बोलो बेटा.
क्वेश्चन नंबर 4 में वो किसी ने बोला था बीच में कि वर्टेक्स निकालने की जरूरत नहीं है, वो इंटरमीडिएट पोजीशन के लिए. तो जो ट्रायंगल बनेगा सर उसके अंदर कोई भी साइड या एंगल 90 डिग्री नहीं है, तो नेपियर रूल लगा सकते हैं उसमें अगर वर्टेक्स नहीं निकालेंगे तो.
Just give me a minute. Question number 4. Let me open up the presentation.
Yes.
Okay, beta, this is question number 4. It basically gives us the two positions. Initial course and distance is to be found. Also find the latitude of the point where the great circle cuts the meridian at 15 degree west. Now beta, बिना वर्टेक्स के आप इसे कैसे सॉल्व करोगे?
सर कल किसी ने बोला था ना वर्टेक्स निकालने की जरूरत नहीं है, वो इंटरमीडिएट ऐसे निकल जाएगा.
Which question was that beta, जिसमें ये बोला था?
यही सर सेम क्वेश्चन थे.
नंबर 4 में.
सर किसी ने तो बोला था इसी में, पर जरूरत है सर निकालना पड़ेगा. किसी ने बोला था बीच में.
बताओ किसी ने बिना वर्टेक्स के इसका सॉल्यूशन निकाला बेटा? एनीवन?
वर्टेक्स का क्या निकालना था इसमें
सर?
बेटा question number 4 में, let me show you the question also. Let me just give me a minute. I'll put the question and the solution side by side.
सर इसको ना 4 पार्ट फॉर्मूले से मैंने किया था सर, इसको तो बिना वर्टेक्स का आ गया था।
ओके 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 ओके।
तो मैंने भी
Yes,
बिना
sir.
वर्टेक्स के किया हुआ है क्वेश्चन।
कैसे किया बेटा?
एक मिनट सर, क्या चाहिए क्या इसमें? वर्टेक्स किस लिए बोल रहे हैं निकालना है? एक मिनट।
ये रहा बेटा क्वेश्चन, यू हैव नंबर 4 क्वेश्चन हियर। So basically initial course and distance is okay. We want to find the position where the great circle cuts the meridian of 15 degrees west. So can you find it out without calculating the vertex?
Yes, sir.
कैसे निकाला बेटा?
तो वही सर 4 पार्ट फॉर्मूला था, उसमें लगाया था, उससे सर आंसर आ गया था।
Okay, all right. Are you comfortable with the 4 parts formula?
Yes, sir.
बहुत बढ़िया बेटा। बेटा I would recommend solving it with cosine formula, Napier rule, and not using the sine formula or 4 parts formula, because जो हमारा 4 parts और sine formula है ये मैंने करवाया भी नहीं है आपको क्लास में। इनमें actually ambiguity का scope है. So in some
Okay.
question you may get the right answer, but somewhere you may get stuck when you are taking inverses of trigonometric ratios. So I don't recommend using the 4 parts formula or the sine formula. That is the reason मैंने उनको touch ही नहीं किया क्लास में.
Okay, sir. Okay.
Okay. So without that, अगर आप cosine formula और Napier rule use करोगे, the method would be by using or calculating the vertex and then finding the intermediate position.
Okay.
सर इसमें ये जो x है जहाँ पे ये 015 लॉन्ग मेरिडियन पे कट किया है वो एंगल 90 डिग्री दिखा रखा है, 90 नहीं होगा ना सर?
नहीं बेटा, this is a mistake in the diagram. This will not be 90. We don't know this angle. This is 5 degrees west, 64 degrees west, and we have 15 degree west in between. No, it will not be 90 beta. So is it okay now beta? Is it clear now?
Yes sir.
Okay, all right. और कोई doubt बेटा exercise में? Okay, great. So shall we move on to the celestial navigation then?
Yes, sir.
Yes.
Okay.
Yes, sir.
Okay. Now basically beta, with this particular question, what we have done till now, we have covered up the question number 4 of our paper. So once you have done these 2 assignments, you can go to any of the past MMD papers and you can pick up and try out question number 4. You should be able to do it. So this what we had done: great circle sailing, composite sailing, calculating intermediate position, finding the vertex. All these things, they are covered up, or they have covered up the question number 4 of our paper. So now we are moving on to celestial navigation, pure celestial navigation. So we will understand the basis, that is the celestial sphere, and on this celestial sphere we have different systems of reference. One is the equinoctial system of reference, with which we specify the position of celestial bodies. Other one is the horizon system, or the observer based system of reference, which can be used to specify the position of celestial bodies. And once we understand these two, then we can move on to learning the concept of PZX triangle. So the plan now is that once we understand this, the celestial sphere, horizon system, equinoctial system, and the PZX triangle, we will be able to solve the rational horizon diagram based questions. So after this, I will be picking up a topic which is star identification. So we will be able to identify the stars in the sky. So basically we are moving into the almanac now. I hope everybody has the nautical almanac with him.
Yes, sir.
Okay, not required right now, but maybe from the next class onwards, we will be requiring the nautical almanac. So we will go into this PZX triangle, then learn the concept of star identification. And this is going to take us about this particular week, I would say. And then we will be entering into our second part, that is the second month, which will start from 15th. So today is 5th. We have about 9 days in between. So from 15th onwards, we will be moving on to the solution of sites. So I will cover up the familiarization with the almanac, and then we move on to solving the sites or finding position lines using celestial bodies with different methods. We have 5 methods which you have done during your second mates also: Marpas, long by Crone, intercept, X meridian, and Polaris. So we will cover up all these parts one by one and then move on to plotting of sites. So that is the sequence, that is the order which we are going to follow. And you are also aware that we are now having a module system. So once we cover up this PZX triangle and the topic of star identification, this is going to basically cover up our first module, that is the syllabus for the first month. Then from 15th onwards, some more candidates will be joining in our batch. So every month now candidates can join. So 15th you will have some juniors joining the phase 1 batch. So I will start off the site solving topic when the new candidates join on 15th. So then we move on to the syllabus for the next month. So that is the plan going ahead. I hope everybody is clear about the plan.
Yes.
Yes, sir.
सर ये
So,
PJT's triangle will be the question number 5 रहेगा ना सर in the MD exam paper.
बेटा ये जो PZX का कॉन्सेप्ट है, ये क्वेश्चन नंबर 8 एंड 9, इनफैक्ट 7, 8 एंड 9, ये जो तीनों क्वेश्चन है आपके, दे कम इन पार्ट सी. इन तीनों क्वेश्चंस में PZX ट्रायंगल और रैशनल हॉराइजन डायग्राम का कॉन्सेप्ट यूज होगा.
Okay sir, thank you.
This is the base concept. So usually people find it difficult to understand. So we will cover it up and इसको मैं एक बार फिर repeat करूँगा आपके साथ. That will be after some time when the new candidates join in and we make some progress. So I will repeat this once again when the second batch or second module is also present. Okay, so let's go into the presentation then and see these systems of reference. Since this is a very critical concept, मैं आज आपके साथ system of reference ही करूँगा. We will see the celestial sphere, horizon system and the equinoctial system. PZX we will leave for the next session. So let's open up the presentation and proceed ahead. In this presentation, we are going to understand the rational horizon diagram. The rational horizon diagram is a very, very important concept as far as celestial navigation is concerned. Most of the problems in celestial navigation can be easily solved or can be easily understood using this concept of the rational horizon diagram. Now, when we are understanding this rational horizon diagram, we will discuss about two different systems of reference which we use to identify celestial bodies. One is known as the equinoctial system of reference, and the second one is known as horizon system of reference. We will understand the concept of celestial sphere, celestial meridians, celestial equator, or the equinoctial, all these things one by one. And once we are comfortable about these concepts, we will be able to easily understand the concept of what we call as a PZX triangle. So PZX triangle is very widely used in many concepts of celestial navigation. So this topic basically forms the basis, the foundation of your understanding of celestial navigation. So let's start to understand these concepts one by one. Now we first move on to the concept of the celestial sphere. Now to understand the celestial sphere, let's make a diagram here. Let's assume that this circle, what we see on the screen, represents the Earth. So we have the Earth on the screen now. Now on Earth, we have our reference system, which is based on the equator and the poles. We know the Earth is rotating about its axis, completing one rotation in one day. And these axes, they pass through the Earth's poles, the Earth's geographic pole, which are North Pole and the South Pole. So let's mark off the poles in this diagram. The North Pole is here in this particular location. You can see it is represented by NP. And the South Pole is here in this particular location. And you can see it represented by SP. So we have both the poles of the Earth marked on our diagram. Now let's show the equator also. Now we know equator is a great circle on the surface of the Earth, exactly midway between the two poles. So you can now see the equator in the diagram. So I have marked the equator. The Earth is shown at a slightly tilted angle. So that is just to make a clear diagram, which is easy to understand. So we have the equator marked in the diagram. It is shown here, labeled as equator on our plot. Now, once we have the Earth, the poles, and the equator in our diagram, we can now proceed to understand the celestial sphere. Now, you see this bigger red color circle in the diagram. This bigger red color circle represents the celestial sphere. Now to define any sphere, we need to specify what is the center of the sphere and what is the radius of the sphere. So we will specify the center as well as the radius of the celestial sphere also. As you can see from the diagram, the center of the celestial sphere is the same as the center of the Earth. So Earth and celestial sphere are both concentric spheres. The center of the celestial sphere is same as the center of the earth. Now coming to the radius of the celestial sphere is assumed to be infinite radius. So the celestial sphere is a sphere whose center is same as the center of the earth, and it has infinite radius. Now, what is the purpose or use of this celestial sphere? Now, this celestial sphere is very, very helpful in solving celestial navigation problems. Now, it is an imaginary sphere. It does not exist in reality. We have assumed this sphere so that we are able to easily calculate the required parameters or the required items which we need, which is basically the position of the ship. So that is what we are interested in. So involving the celestial bodies, the sun, the stars, planet, and the moon, all these 4 different celestial bodies, we have the sun, we have the moon, we have various stars, and we have 4 planets which are used for celestial navigation. So involving these objects and finding our position on the surface of Earth, fixing up the ship's position, was made possible only with the assumption of this celestial sphere. As I told you, this is an imaginary sphere. We have assumed it. Now, how does it help us to get the items or solve the questions which we need? How does it help us to find the position? Now, this celestial sphere, as I told you, it is assumed, it's an imaginary sphere. We consider that all the celestial bodies are situated on the surface of the celestial sphere. Whether it is the sun or the stars or the planets or the moon, we consider all of them to be situated on the celestial sphere. Now, once these bodies are considered to be situated on the celestial sphere, we are able to use our knowledge, formulas related to spherical trigonometry to solve them. So we know spherical trigonometry is the branch of trigonometry which works on the surface of a sphere, on the 3D curved surface of a sphere. We have a few important formulas. Just to name, cosine formula and Napier rule are a very important relations or formula in spherical trigonometry. So once you consider all the celestial bodies to be situated on the celestial sphere, we can easily use these formula to calculate the required items which we need for our purpose, or we can use it to fix up the position of the ship. So that was the advantage or the purpose of imagining this celestial sphere. Now, just like we have references on the surface of Earth to fix up the observer's position, similarly, we also have some references on the celestial sphere to specify or fix up the position of the celestial bodies. On the surface of Earth, the references which we use are the equator. We can specify the latitude of a position using the equator. It tells us how much, the latitude basically tells us how much north or south of the equator a particular position is. And the second reference which we use are the meridians. Meridians are semi-great circles passing from the poles, North Pole and the South Pole. We have the Greenwich meridian as our reference meridian, and we have the meridians running 180 degrees east and west of the Greenwich meridian. So they give us a reference to calculate or find out the longitude of a particular position. So this is the reference what we use on the Earth's surface, the latitude and the longitude. Now, how to specify the position of celestial bodies on the celestial sphere? So for this, we have made some references, and they are very much similar to the references on Earth. So let us now see the references which we have on the celestial sphere. Now we know that the Earth rotates on its axis, completing one rotation in 24 hours. Now these axes pass through the poles, the North Pole and the South Pole. So let us mark this axis of the Earth in this diagram. And let us extend this axis to the celestial sphere. So you can see this dotted line. This dotted line basically represents the axis around which the Earth rotates. The points at which it cuts the Earth's surface are the North Pole and the South Pole. They are already marked in the diagram. Now, if you extend this axis of the Earth or you project them up to the celestial sphere, you see the axis of the Earth projected onto the celestial sphere or extended to the celestial sphere meets the celestial sphere at this particular place. Now, this is known as North Celestial Pole, represented by NCP, which stands for the North Celestial Pole. Similarly, the axis of the Earth extended towards the South Pole of the Earth meets the celestial sphere at this particular location, and this is known as the South Celestial Pole. So you have the South Celestial Pole marked on the diagram as SCP. So these are the two celestial poles which we use as our reference. Now, exactly same as we have the equator on the surface of Earth, equator is a great circle which is equidistant and exactly midway between both the poles, the North Pole and the South Pole. Now, in an exact same manner, a great circle on the celestial sphere exactly midway or equidistant from the North Celestial Pole and the South Celestial Pole is known as the celestial equator. So you can see resemblance in the names. We have it as a equator on the Earth's surface, and when it goes to the celestial sphere, we call it celestial equator. Other name which is more common in navigation terms is the equinoctial. So we also call it the equinoctial. The north and south poles, when they are projected onto the celestial sphere, are known as the celestial poles. The equator, when it is projected onto the celestial sphere, is known as the equinoctial. So let us show the equinoctial also in the diagram now. So you can see this red color great circle, which is located on the celestial sphere, exactly midway between the north celestial pole and the south celestial pole. This is the equinoctial. So you can see it labeled in the diagram. Now you can also understand equinoctial from a different perspective. If you extend the plane of the equator outwards, the plane of the equator is extended outwards, or you can say if the equator is projected onto the celestial sphere. So you can assume that there is a light source at the center of the Earth, and the equator is casting its shadow. A shadow is being cast on the celestial sphere, and that is also known as a projection. So this shadow, wherever it hits the celestial sphere, forms the great circle which we know as equinoctial. So we have the equinoctial in the diagram, we have the north celestial pole and the south celestial pole in our diagram. These are used as reference points to specify the position of any celestial body on the celestial sphere. Now, how do we use it as references? This is also very similar to what we do on Earth. On Earth, we represent a position using its latitude and longitude. Now, latitude is referenced to the equator. The latitude of a place basically tells us how much north or how much south of the equator a particular position is. Exactly in the same way we use the equinoctial. We first find out whatever celestial body we want to specify, how much north or how much south of the equinoctial that particular body is. And on celestial sphere, we call it as the declination of the body. So the job of latitude on the surface of Earth is done by the declination on the celestial sphere. So if you have the declination of any celestial body, it immediately tells you how much north or how much south of the equinoctial that particular body is. So that's how we use the equinoctial as our reference. Now, for the longitude of any place on the surface of Earth, we use the meridian of Greenwich. We use the Greenwich meridian as our reference meridian, and we find out how much east or how much west of the Greenwich meridian that particular body is. Now, on the celestial sphere, we have two references. One is exactly similar to Greenwich, which is the celestial meridian of Greenwich. What is the celestial meridian? Now, a celestial meridian is very much similar to the meridian which we have on the Earth's surface. The meridians are semi-great circles joining both the poles of the Earth, the North Pole and the South Pole. Now, in the same way, a celestial meridian is also a semi-great circle on the celestial sphere joining both the celestial poles. So you can see a green color dotted line on the screen now, highlighted by the laser pointer. So this dotted green line is a great circle which is passing from both the celestial pole, the north and south celestial poles. Now this is what we call as a celestial meridian. We can have infinite number of great circles passing from both these poles, as these are diametrically opposite points. Now, if we project the meridian of Greenwich onto the celestial sphere, wherever it projects or falls, that is called as the celestial meridian of Greenwich. Now, celestial meridian of Greenwich is used as a reference to specify the position of a body, but we do not use the longitudes on the celestial sphere. What we use on the celestial sphere is GHA, Greenwich R angle. So Greenwich R angle is measured with reference to this celestial meridian of Greenwich, and it is measured in the westerly direction. So just as we have the Greenwich meridian as a reference on the surface of Earth, we have the celestial meridian of Greenwich on the celestial sphere as a reference to specify the position of any celestial body. So if we get the declination and the GHA of any particular celestial body, we will be able to fix up that body's position on the celestial sphere. The declination will tell us how much north or south of the equinoctial that body is, and the GHA, Greenwich R angle, will tell us how much west of the celestial meridian of Greenwich that particular body is. So it will specify the position on the celestial sphere. Now, a second reference is also used in terms of specifying the meridian of the body. The second reference is used with respect to a particular position on the celestial sphere, which is known as first point of Aries. Now later on, I will discuss with you the concept of ecliptic, Ecliptic is basically the path of the sun projected on the celestial sphere. Now this ecliptic cuts the equinoctial at two places, and these places are known as first point of Aries and first point of Libra. So if you use this first point of Aries as your reference and you measure the angle westwards of this first point of Aries, it is known as SHA, sidereal R angle. So these are the two references which we use to specify a body. Either we use the GHA, measured from the celestial meridian of Greenwich, or we use the SHA, sidereal R angle, which is measured from the celestial meridian of first point of Aries. So this is the equinoctial system of reference on the celestial sphere. Important thing to keep in your mind is we should be clear about the concept of equinoctial. We should be clear about the concept of what a celestial meridian is, and with it we will be able to easily understand the concept of declination and GHA or SHA. So this is the equinoctial system of reference on the celestial sphere. Now beta, any doubt up to here in any of the things? Have a good look at the diagram. This is basically a 3D kind of diagram of the celestial sphere. We are trying to make it on a 2D plane surface. So just have a good look at the diagram, see the references, and let me know if there is any doubt. Okay, so that tells me all clear. So धीरे धीरे याद आ रही हैं बेटा चीजें अब माइंड में?
Yes, sir.
Yes, sir.
Okay, very good, very good. So let's stop it here, beta. We are almost going to finish off the first session. So let's stop it here. Next session, when we meet, we will go ahead with the concept of horizon system. Horizon system will tell us about the rational horizon, the sextant altitude of a body, and the LHA of a body. So we will see the horizon system next. So that's all for this particular session. So you can break off for your tea, beta. So I'll see you in the next session. Till then, bye bye.
Thank you, sir.
Okay,
Thank
beta.
you.
Thank you. Thank you.